A payment service container ran out of memory every 3 hours. The culprit? A startup handler that opened AOP sessions, but Shutdown never closed them because an exception skipped registration. Let's break down FastAPI Lifespan Events, startup, shutdown, and context managers, how it works, and the exact mistake behind that failure. Think of your FastAPI app as a food truck. Startup is when you open the shutters, turn on the grill, and stock the fridge. Shutdown is when you clean up, turn off the gas, and lock up. The Lifespan Context Manager is like a checklist that guarantees you do both in order, even if a health inspector shows up mid-shift. The old decorators look clean but hide a nasty flaw. They don't compose. If you have 3 startup handlers and the second one throws, the first one's resources never get cleaned up. In production, that means leaked connections, open file handles, and zombie threads. Here's the bug in action. If the second startup handler raises an exception, the shutdown handler never runs and the database pool is leaked. This is exactly what caused the OOM incident. FastAPI's lifespan parameter accepts an async generator. Everything before yield is startup, everything after is shutdown. The generator is wrapped in a context manager, so even if startup throws, the cleanup runs. This is the only pattern you should use in production. Here's how a checkout service initializes its database pool, cache client, and external payment gateway client. Notice the try finally, belt, and suspenders. Even though the context manager already guarantees cleanup, it makes the intent explicit. When Kubernetes sends SIGTERM, your app has a few seconds to finish in-flight requests and close resources. The lifespan shutdown runs after the server stops accepting new connections, but before the process exits. Always wrap cleanup in asyncio, wait with a timeout. Here's the pattern for Graceful Shutdown. We cancel all background tasks and then wait for them to finish with a timeout. Never use asyncio.gather without a timeout in shutdown, it can hang forever. You can't test lifespan events with a simple test client because it doesn't trigger the lifespan by default. You need to manually enter the lifespan context using app, router, lifespan context. This catches the exact bug that burned us in the incident. Here's how we test the checkout service lifespan. We assert that the pool is created after startup and closed after shutdown. Knowing that test client doesn't trigger lifespan by default is a common interview trap. If you're writing a tiny internal tool that runs one request and exits, don't bother with lifespan. Just open connections in the endpoint and close them in a finally. But for any service that stays running and handles concurrent requests, lifespan is non-negotiable. For a cron job style script that calls one API and dies, a simple with block is cleaner. But the moment you add a second route that uses the same database, refactor to lifespan before you forget. Sometimes you need to pass lifespan resources to background tasks or dependencies. The cleanest pattern is to store them in app state and access them via request app state in dependencies. But beware, background tasks that outlive the request may try to access app state after shutdown. Here's the pattern for dependency injection with lifespan. The getDB dependency accesses the pool from app state. Never store resources in global variables. Use app state, it's designed for this and works with multiple workers. This is the same issue we highlighted at the start. Here's exactly why that happened. The old app on event decorator opened a new AOP session on every worker start, but when another startup handler crashed, the shutdown never ran. Sessions accumulated until the container ran out of memory every 3 hours. The old app on event decorators do not compose. If one startup handler crashes, previous handlers' resources are never cleaned up, leading to connection leaks and OOM. The fix was to replace both decorators with a single lifespan context manager. The yield cleanup runs even if startup partially fails. We added session close in a finally block. This ensures the session is always closed, preventing the leak. This is the exact mistake from the incident. The startup handler opens a session, but if another startup handler crashes, the shutdown never runs and the session leaks. Always use the lifespan context manager to pair startup and shutdown. Never store resources in global variables. Use app state, It's designed for this and works with multiple workers. Global variables can cause race conditions and are not safe in multiprocess deployments. Never use asyncio.gather without a timeout in shutdown. If one task hangs, your entire shutdown hangs, and Uvicorn kills the process ungracefully. Always use asyncio, wait with a timeout. The lifespan parameter was introduced in FastAPI, March 2023. If you are on an older version, you must upgrade or continue using the deprecated app on Event Decorators. Check your FastAPI version with FastAPI version or import FastAPI, print FastAPI version. To ensure your app shuts down within a specific time, configure timeout Graceful Shutdown in Uvicorn. This complements the asyncio wait timeout in your lifespan shutdown. Example, run with Uvicorn app timeout Graceful Shutdown 10 to allow at most 10 seconds for shutdown. When running with multiple workers, e.g., Uvicorn workers 4, each worker runs its own lifespan independently. Resources like database connection pools are per process. Do not assume shared memory between workers. Use external services, Redis, PostgreSQL, for cross-worker state. Lifespan ensures each worker cleans up its own resources. Here's how to diagnose and fix the common failure modes. First, check if you're using the deprecated app on Event. Replace it with the Lifespan Context Manager. Ensure pool close is called in a finally block. For shutdown hangs, use asyncio, wait with a timeout. Let's run through some common interview questions. How does Lifespan handle exceptions during startup? Context Manager's exit runs cleanup after yield, releasing acquired resources. When to use Lifespan Vs with block. Lifespan for long-running services with shared state, with block for single endpoint scripts. What happens if you forget to cancel background tasks in shutdown? Tasks prevent event loop from closing. Uvicorn kills process after timeout. And a few frequently asked questions. Should I use it app on event in production? No, use Lifespan. App on event is only for quick prototypes. How to test Lifespan events? Wrap test client inside a sync with app router, Lifespan context, app. What's the biggest mistake in shutdown? Using asyncio.gather without a timeout, it can hang forever. To recap, always use the Lifespan Context Manager, never the deprecated app on event. Wrap cleanup in try finally. Use asyncio, wait with a timeout in shutdown. And test Lifespan events with app, router, Lifespan context. Ready to go deeper? Up next, FastAPI streaming responses and file responses, then FastAPI async SQL alchemy, then FastAPI cloud. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.